Hello everyone, welcome to this video. In this video, I wanted to cover cloud computing concepts and architecture. If you are new to the cloud, there are a few things that you should know. And hopefully this video will give you a lot of understanding about the cloud and when you're moving to the cloud, some of the terms that you need to know. And especially in terms of security, there are a few concepts that we're going to cover. Now, this presentation I kind of based on a publication from CSA, which is Cloud Security Alliance. And even before I start, I want to put the reference in here so you can go in depth and read the whole chapter. And this kind of covers the domain one from this particular book, Security Guidance for Critical Areas of Focus in Cloud Computing. And I'm using the version 4.0. So even before we talk about the cloud and cloud deployments, if you think about the cloud, what is it? It's something, there are few things that are associated with cloud, and these are amazing terms. Transformative, disruptive, exponential growth, agility, resiliency, and economy. So now let's look at each of these terms just a little bit. Okay, transformative means cloud. You have new innovation, new technologies that are coming, things that you can never do in your on-prem environment. New solution. People are doing crazy things with the cloud. It's transforming the way we think, the way we build our software, the way we build our application, the way we think about security. Okay, it's transformative. It's a new way of looking at things, new way of doing things better using AI, using ML, things like that. Disruptive. So think about the cloud. It's just taken over the whole world as a storm. It's a disruptive technology. No one ever thought that hundreds and thousands of people will move to the cloud, and that kind of lies goes on with the exponential growth. So we had Amazon, and then Azure came. They took a big share of the market. Google Cloud is growing exponentially because of their powerful offerings for data analytics and stuff. And other terms, agility means you move fast. Now, if you want to build a data center, you don't have to wait, you don't have to purchase big hardware, don't have to configure anything or little, you don't have to hire professionals. So you can just go and get all the stuff that you need using some buttons, and then you configure whatever you need. It's you move fast. Resiliency. So cloud is really built for resiliency. So your principle, your idea is things are going to break in the cloud. So you build your application, your solution to be resilient. Once something goes down, you will spin up another one. So thereby you reduce the downtime. And economy. So the properly, if you're using the cloud, you should be reducing your cost. Okay, so that's another great benefit to move to the cloud. Now, what do you need to understand as a cloud consumer? Okay, so there are a few things that you need to know. Cloud native models. What are cloud native models? You should have a little bit of idea. Then you need to utilize exciting cutting edge features that I told you, that brings to the table. You need to utilize as a consumer. You need to know what are the services that Amazon is offering, what are the services that maybe IBM is offering, Google is offering, and who does what best. So understand that. So don't just lift and sit. Don't just take your application and your virtual machine. Maybe you're using VMware in your on-prem. Don't just take it and put it on the cloud. A lot of people start that way. But think about, can I do things better? Can I give our maybe the patching responsibility of our servers to the cloud? Maybe a PAAS environment may be more suitable for us. Okay, think about that. And once you are moving, understand the cloud and what kind of feature it provides, and use that to re-architect your solution if needed. You build your solution for the future. Okay, that's important. Now if you think about cloud computing and what it is, we all have some basic idea at this point. If you look at the official NIST definition for cloud computing, NIST says cloud computing is a model for enabling ubiquitous, convenient, on demand network access to a shared pool of configurable computing resources. That is, network, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So, what it really means, once you have access to one of these cloud providers, say GCP, Amazon, Azure, you have a portal. Then you don't go and bug Google or Amazon and request for something and then wait 3 days or a week to have the resources available to you. You just go there and spin up resources just like that. Okay, you provide, and if you don't need it, again, you don't have to go and request, hey, take down my server, I don't need it anymore. You just get rid of it. It's that simple. Now there are a couple websites you can go to, and actually let's go and let's if we just take a look at some of the services that you see. So this is like Google Cloud. You can go to any other cloud, and if you go to the products, look at how many different kind of services they have. They have AI, API management, compute, containers, data analytics, databases, developer tools, healthcare, life science. They have specialized tool, hybrid and multi-cloud, IoT. See, all products, they have 100 plus offerings. And here are some featured products over here. Compute engine, that's basic, that you have to have your virtual machine. You should be able to select how much RAM you need, how much memory you need, stuff like that. Cloud storage, you have to store your data. Cloud SDK, a tool to interact with your API that will call the management plane to deploy your resources. Cloud SQL, if you have a SQL type database, so you can use that one. Kubernetes engine, we have BigQuery, Cloud CDN for the content delivery network, data flow for the streaming analytics. Then we have operations that you can use for monitoring login and application performance. Cloud Run for containerized application. We have Anthos. So tons and tons and tons of things. Okay, so all of that you can open up in a second and then get rid of it. Now there is, if you need to know more about this cloud training, you can go to this NIST publication, and again I have given you the link. This NIST definition of cloud, it's a only 7-page document. It has the full documentation, and then some other stuff in here, like essential characteristic of your cloud on demand. So you want something, you get it. Broad network access, you can be anywhere in the whole world, you should still be able to access your cloud. Resource pooling, that means the cloud provider, they have a pooled resource, so multiple customers, I can go there, I can get a virtual machine, you can go there, you can go a virtual machine, and I don't know that what you're using, and you don't necessarily know that what I am using. Rapid electricity, so if based on my demand, I should be able to scale my application automatically or manually, whichever way it is. And then metered service, I should be paying for the services that I'm using. So if I have a cloud and I don't have a virtual machine, I should not be paying for the virtual machine. So that's some of the essential characteristic of the cloud. Service model we're going to cover. So let's go back to our slide. So before we go there, let's cloud user and cloud provider. Basically, the client or cloud user is myself or you, probably, most likely, who is going to use the cloud. And cloud provider would be like the Google, the IBM, the AWS, Azure, any of the cloud providers who is providing the service to you. Now, when you think about the cloud, there are two terms that are extremely important to understand. One is called the abstraction, another is the orchestration. Okay, so abstraction is probably the simpler between these two understand. So you are abstracting, or cloud abstracts all the difficulties or all the minute details of physical hardware. Okay, then maintaining the hardware. You don't need to know any of this. Okay, maintaining hardware, changing disk, if there is a disk failure, all of that is abstracted. Okay, and orchestration is Now you have ways to automate and call the management plane to get whatever you need. Okay, so in a traditional virtualization, this orchestration part is actually missing. So in a cloud, you have access to the portal, you have access to the API, you go and you orchestrate, you automate things to spin up new virtual machine, new servers, new databases, new SQL, new functions, and when you don't need it, you get rid of it. And network. Okay, and the other thing, most cloud, when especially the public cloud, it's multi-tenant. So it's not just you are going to use this. I can go and use the same cloud provider. 100 other people can go and use the same cloud provider, but uh, you would not know what I'm deploying, and I would not know that what you are deploying when using the same provider. Okay, so the service model, we have three service model are the major. Okay, platform as a service, software as a service, and infrastructure as a service. And a lot of time you will see many other terms like database as a service, security as a service, and whole bunch of other terms. So but the main three are infrastructure as a service, platform as a service, and software as a service. I should have written it that way. So the reason I'm saying I should have written it that way, because infrastructure as a service is where you are really lift and shift. You are doing lift and shift. You are just really moving your own on-prem infrastructure. You have reviewed you need 10 gigs of virtual disk space. You need 8 cores machine and 5 gigs of memory, something like that. And then you configure the exact same virtualized machine on the cloud. You take the application and move it there, or just take a whole snapshot of your machine and just spin up another one over there. So that's infrastructure as a service. Platform kind of abstracts your operating system, and it gives you all the application type thing. Like it will give you say Python and the application runtime environment it will provide. So you are kind of, you don't have to worry about maintaining and managing any application, any operating system features, patches, anything like that. It will give you everything. Say you are a lamp developer. Okay, so it will come with all the stack that you need to develop an application. Okay, and the SaaS is where you are even more abstraction. So now you're using software as a service, so you don't even have to worry and build your application. So the typical use case here, you just want to move your server. In PAAS, most likely you have already an application that you have internally developed, and you don't want to maintain the operating system anymore. You just want to have the runtime environment and everything. So you go with the PAAS, but still you are deploying and maintaining your own application. And SaaS, the application is not even developed by you. It's the cloud who has developed the application, and you started using it. Like say even Google AD, Gmail, okay, Box, all of those are SaaS services. Now let's go to deployment model, and before we go that, let's come over here. So we talked about software as a service, platform as a service, infrastructure as a service. Those are the three, as I said, even from NIST, those are the three main. And again, I said you might see database as a service and security as a service, things like that. But these are the three that you absolutely need to know. So again, so we have covered a whole bunch. Now the next thing that we're going to cover is the deployment model. So what are the deployment models? So come over here. So there are four major deployment model. Public cloud, where just what it says, it's public, so it's available to all public. So I can go, you can go, everybody can go and have their own access to the provider. Private cloud is where you are using the cloud technologies to create your own data center, and no one else has any access to it. For example, Azure Fabric. If you can get the Azure Fabric, okay, let's do a quick search. Azure Fabric, okay. So Azure Fabric is distributed system platform that makes it easy to package, deploy, and manage scalable and reliable microservices and containers. I think one of these services you can use, and you can actually uh, create your own cloud infrastructure. Okay, and in that case what happens that only you have access, so it's not a public, but you are virtualizing and maintaining all the hardware itself, but you are not installing stuff on the hardware. You are still using a hypervisor and using some kind of virtualization tool to virtualize your whole environment, but no one else has access. So that's private. And community is when two or more organizations they come together and you are sharing some resources, but it's still not available to the public, but it's only available to couple or three or four or whatever be the number is, number of organizations. And hybrid is when you have multi-cloud maybe, okay, Azure and AWS. It could also be Azure plus on-prem or Google plus on-prem. So it's a hybrid, and it just that it's a hybrid environment. So again, if you look at kind of the definition official, private cloud, the cloud infrastructure is provision for exclusive use by a single organization comprising multiple consumers, business units. Okay, it's still it's a one, it's a privately owned. Okay, it may be owned, managed, and operated by the organization, a third party, or some combination of them, and it may exist on or off premise. So again, private cloud doesn't mean it has to be on prem, it could also be off prem. Community cloud, when the cloud infrastructure is provided for exclusive use by a specific community of consumers or organization, as we said, then it will be treated as a community. Public cloud is most common. It's where the cloud infrastructure is provisioned for open use by general public, like Azure, like GCP, like Amazon. And again, hybrid cloud, as I said, the cloud infrastructure is a composition of two or more distinct cloud infrastructure, private, community, or public, that remains unique entities but are bound together by standardized or proprietary technology that enable data and application portability. All right, let's go back over here. So this diagram that I got from the book that I told you is from Cloud Security Alliance. So this kind of summarizes the essentials of a cloud. Okay, we talked about the resource pooling. So they have a whole bunch of resource pooled, and pretty much you are now going to use, I'm going to use, some other person is going to use. We have broad access to network. We can create network. Most in networking is software defined network. We have rapid elasticity. We can respond to demand. If there's no demand, we can drop down. Measured service, we only pay for the services that we're using. And on demand, we can spin up anything whenever I want. I can get rid of stuff whenever I want. Again, service model, we talked about SaaS, PAAS, and infrastructure as a service. Deployment model, we talked about public, private, hybrid, and community. All right, so reference model. So this is again just a summary type what we kind of talked about. A reference model for the cloud. Again, your abstraction and orchestration, we talked about those two different terms. So if you look at it over here, this figure is coming from the same book. At the bottom, you have something in green. Okay, so what this picture is very interesting. So infrastructure as a service, you have this box. Then on the top of it, you have the PaaS or the platform as a service, and even at the top of all of that, you have the SaaS or the software as a service. So when you think about the cloud, you can also kind of think about this way. So you have the facilities, hardware, and then abstraction and core connectivity and delivery. So pretty much all of this is provided by your cloud provider, okay, CSP. And then you have the management plane and APIs. You can call the APIs using SDK, using code, using programmatic languages. Most people, they will support the REST endpoints. And you can also go to the cloud portal where you can do things, anything that you want from a UI. So UI really calls the API at the back end and do whatever you want. So when you are still working at like operating system level, you are still infrastructure as a cloud, infrastructure as a service. PaaS even as abstracts all of that and even gives you an environment to run your application. So integration and middleware comes there. And software as a service kind of where you have presentation modality, presentation platform, other APIs, applications, data, metadata, and content. Okay. uh, so one thing to remember, that this application or this management plane, okay, that is critical for you to protect from a security standpoint. Because think about it, it's everything is virtualized, and anybody who has access to the management plane can do a lot of damage if they're nefarious. Okay, so make sure that you have a very good understanding about the access control in your cloud environment. As a matter of fact, access control is called the new security plane, new control plane in the cloud, where you should pay a lot of attention. Okay, so here I have given you some example. Infrastructure as a cloud, you have VM, your network, your storage, platform as a service. There are a whole bunch. Azure SQL is a good example, App Engine is a good example, and then software as a service, Microsoft 365, Azure AD, Gmail, tons and tons of them. Now we could do a demo, but I'm gonna skip it. I have done so many demos on VM deploy, and you can do a search, virtual machine deploy using Azure or Google Cloud, Azure App Service, Azure AD. So these are just something that you can do yourself and kind of learn three different types of deployment within a cloud. Okay, so we are here. So the next thing uh, that you should know is there are some logical models and security when it comes to the cloud, and they have little interesting term: infrastructure, metastructure, infrastructure, and apply structure. So infrastructure is simple to understand. Here you are looking at infrastructure security. Infrastructure means information, so that means you are looking at data security. Apply structure means the application security, whatever application you are building and running, securing those applications. Now metastructure is the one that usually not present in a traditional on-prem environment. Here you are actually looking at the management plan and making sure that your management plan is completely secure. So again, logically think about, when logical security, you can think about, okay, information security, and maybe you have separation of duties, and you may assign one person, okay, you take and look at the infrastructure security. One person, okay, you are responsible for the data security. Another person, all right, you are now looking at all the application and make sure all the applications are secure. Okay, this one, again, when you're thinking about security, you need to think about the responsibility roles and models, and different services. When you are using infrastructure as a service, platform as a service, software as a service, your responsibility varies, it changes. And it 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 is maximum when you are at on-prem, so you have to manage everything, and it's the least when you are running as a software as a service. But never think that you are completely not responsible for anything. Even over here, really, your users and their access is critically important, and you are going to be responsible always, no matter where you are, what deployment model you're using, you are still responsible for that. But this is kind of showing, and this is I got this image from medium.org, and you can get it from this link. So they have on-prem, everything is blue, that means everything is your responsibility. Infrastructure as a service, virtualization, server, storage, networking, your cloud provider will take care of that. Okay, but you're still responsible for OS, middleware, runtime, securing your data and applications. So all the software patches, everything you have to do, middleware update you have to do, runtime environments. So if you want to run Python, you have to install it. Data security, you have to take care of it. Application, you have to take care of it. When you move to platform, you have more separation. So your cloud provider is going to provide the runtime, middleware, operating system. Now you're not worried about the patching here, virtualization, server, storage, networking, all of that. So here you focus on building your application, running your application, and securing your data. And when you are as a SaaS, even more, your application is even provided by the cloud. The data piece, I don't 100% agree. I think data is something that you should be responsible to some extent for sure. Even though you are using a software as a service, data, I feel you should be always extra careful and always think that is something that you should protect yourself, not just give everything and not completely rely on cloud provider. At least make sure whatever tools they're offering, they're configured properly, because data is where your value is. Most company, data is critical for their business. Okay. All right, so couple recommendation that I can give you is when you are choosing a cloud provider. Okay, so you use this consensus assessment initiative questionnaire and you give this to your cloud provider, or you do your own research and fill out this form to evaluate cloud providers. So that is before you are choosing a cloud provider, you do your due diligence and you figure out which one is the best. Okay, again, this is coming from the Cloud Security Alliance, and let's just go there real quick. So if we go there, you look at this is version 3.1 at the moment. Version 4 is coming out sometime in the future, but right now is the version 3.1. And what it is, if you download, it will give you a really long Excel spreadsheet. And what you can do with it, let's just download maybe and open it real quick. So in this one, what you will do, it has a little description how and what how to use this one. This is provides a cloud consumer and cloud auditor with the opportunity to ascertain that their cloud service provider is compliant to the cloud control metrics, CCM. So this is something else that you would look at. So what you do, you have all the questions and the control domain. There are a whole bunch of 8 or 9 control domains in here, and they have a specific set of questions in here, and you just go through and answer whether you have that control available or not, and you make notes, and then you give it to 3 or 4 different cloud providers and get answers from them, or sometimes they will also publish this information on their web, and you can review and compare and figure out who are meeting the controls that they should be meeting for cloud security in a cloud environment. Okay, so that's good. So let's come back over here. The other one, for yourself, you also need to build a framework. Okay, and you can use the cloud control metrics as a guide. And what I suggest that you build a responsibility matrix. Okay, and document that who is responsible for what. Who is responsible for data security, who is responsible for network security, who is responsible for a SOC, who is responsible for incidents management. Okay, document all that, and again you can go there. And this control matrix is also, it's a document, an Excel spreadsheet, and here you have again the control domain, and you have the control ID and control title. You can read and you can assign, okay, this to meet this, I need this person. Now one person could do multiple of this, so you don't have to choose like one person for every single control. That would be ridiculous. But you know that okay, if there's something, a problem or issue or question come up, I can go to this person. And identify your gaps. Okay, it's these documents, they're meant for you to identify what you have currently, and figure out what are the gaps, so you can work on it and fix the gap to improve the security in a cloud environment. Okay, so those are my 2 recommendations, and again I'll give you all the links of this document in my video at the end. Okay, so the next thing, cloud security model. So now we kind of understand, okay, we have security. uh, so how do we validate, how do we secure our cloud. Okay, to do that, we can do few things. We can look at the uh, conceptual model. And CSA, the Cloud Security Alliance, has a really nice and logical model, and we'll take a look into that. You can also look at control models for framework, which is the CSSCCM that we kind of looked at. Okay, right? And you can also have reference architectures. Some of the reference architectures, they can be very detailed, and it will tell you exactly how to implement some of the security controls. And there are also some design patterns that are specifically developed for the cloud, and these are usually reusable. So once you learn a design pattern, you can reuse those patterns. So that's also very valuable. Again, so the security model, you can use the CSA enterprise architecture, and if we look at that one, that one is like a huge big one page document, and it has a lots of stuff in here. So if I open this one and increase the font size, so here is a guiding principle over here. How do you use this high level use cases, end user to cloud, enterprise to cloud, and enterprise to cloud to end user, and here enterprise to clouds. Okay, and end user, they have flow diagrams, what you should be doing and how you should be doing. And then over here they have business operations support. So this is the reference architecture. If you look at it, under here you need to have compliance, you need to have data governance, and what are the things that you need to do. It's very detailed. Information technology operations and support, you have IT operation, you have DRP, IT governance, project management, portfolio management, then service delivery, SLA, resiliency, then human resource security, operational risk management, security monitoring. There's a whole bunch in here, really important. Same event mining, database monitoring, application monitoring, honeypot, endpoint monitoring, okay, anti-phishing, then service support, configuration management is very important, incident management, problem management, knowledge management. Then for legal services, you have contracts, e-discovery, forensic analysis, then email journaling, all those different things. And over here, even more presentation services, application service. So this is a really really good reference document that you should have, kind of, to understand, okay, what do I need to do when I'm moving to the cloud. Okay, what are the different components? Do I have this? Do I have that? Maybe print out a really big document in a big page and just hang in your wall, and kind of look at it time to time, and see where you stand. Really good, really nice document, really nice reference diagram. The cloud control metrics, we already talked about this one. And then you can also go to this ISO IEC 27017 information technology security technique. So if you go there, there's another place you can go. Code of practice for information security controls based on this for cloud services. So ISO 27001 is the most popular one that you get a certification. So your company is meeting that international standard, and this 17 is specifically built for the cloud services. So you can also use this document to validate your cloud environment. All right. The next thing is a simple cloud security process model. So this is from Cloud Security Alliance again, and this is a very simple way to understand the security in a cloud deployment process. So they have one, two, three, four, five, six, seven different steps. Okay, and each and every step is actually important. So even before you do anything, you identify your requirements. What are we going to do with the cloud? Then you go through that questionnaire and figure out which provider you're going to use, what services you're going to use, and what kind of deployment model you're going to use. Are you going to use PAAS, SaaS, infrastructure as a service? What? Then once you have identified that, your provider and the services, you define your architecture. Okay, once your architecture is done, and you are building again for resiliency, for scale, for high availability, for disaster recovery, for backups. When all of that done, you think about securing all those, okay, as you are building. Security comes everywhere, so you make sure that all of the deployments and architecture, they're built securely. And then once that's done, okay, now we can do this. Now who can do this? What one person can do this when you're deploying, and who is going to access your data? Access security controls. Now focus on that and develop your active directory solution, your access reviews, all of that, policies, everything. And again, then stop and then think about where you are. Identify any control gaps. Do you have any? Is there something that you can do better? Is there a security control that you're missing? Identify and work on it. And then, if, as I said, if there's any control gaps, you design and implement these controls. And at the end, you have everything. Then make sure that people are not randomly changing things and breaking stuff. You control any, manage any changes within the cloud environment. Okay, so that kind of gives you the 7-step process, which is a simple cloud security process model to identify different areas and different phases where you should look at security. So other thing, so areas of critical focus, so 13 different domains. Okay, generally CSA, they have these domains divided into two different parts: governance domains and the operation domain. And where what we are really doing is in the domain one, which is the governance and enterprise risk management. We're kind of talking about those. So under here you have that, you have legal issues, you have compliance and information governance. Now then operations, which is more like how you're utilizing the cloud, management plan, security, infrastructure security, virtualization, container, incident response, application security, data security, encryption, security as a service, and related technologies. Okay, so let's go over them real quick and then we will end this chapter. So governance, when you think about governance and risk management, is very important in the cloud. You have to govern and measure enterprise risk when you move to the cloud. What are the risks the cloud is bringing into your organization that was not there before when you were all on-prem? What's going to happen if there's a SLA breach? If the cloud service is down? Think about Azure AD. So time to time I see that Azure AD is down for hours to 4 hours, 8 hours. It creates a huge impact. Especially that's like a single point of failure for many of us if you're only using that authentication or authorization method. Okay, so that creates a lot of problem. Shared responsibility, do we understand who is securing what? International boundaries. Okay, do we have any data specific requirements and laws that I can keep and store my data in certain areas in certain countries? Okay, so maybe you're working for the government, which other countries, for one particular country they may say no, you have to keep all the data in our country only. Legal issues, international laws, so that could be complex. Data privacy, security breach disclosure, it could be different in different parts of the world. And since cloud is all over the world, okay, you sometimes don't even know where exactly your data is stored. You gotta understand a lot of laws and regulations to make sure that you understand how your data, how your applications are behaving, where it's stored, and how the data is flowing. Compliance, we talked about it. You have to meet compliance, your enterprise security compliance that you have on prem. You also want to make sure that similar or even better compliance standard is there on the cloud. You don't want to lose anything when you move to the cloud. For example, a lot of businesses, they use CIS benchmark to meeting compliance for databases, for operating systems, for middlewares. ISO, do you have to meet with ISO? GDPR could have some compliance requirements. NIST, another 855 maybe, that you can use to implement various controls in your cloud deployment. Then comes information governance: when and how to store your data in the cloud, who maintains the data, who performs the backup of your data, what are the controls do we have to protect any sensitive data, and how to apply data classification in a cloud platform. Okay, you have to think about all of that. So those are kind of the governance part of it. Then we move to the more infrastructure part of it, or operations part of it. The first one is the management plane and business continuity. Here it is again, it's very important to secure access to the API. It's a new control plane. If somebody get access to the management plan that you're using, then they can do some serious damage. Secure access to cloud portal is very important, and ensure business continuity is also very very important, and kind of covered and jumbled together, bundled together under one heading by CSA. Then the next one that I have is for infrastructure security, and it says exactly what it says: security for compute and networking, all the infrastructure services that you need. The next is virtualization and container. Here you have to secure your containers, secure your hypervisor, and secure software-defined network. The next one is for incidents response, notification, and remediation. Here you have to think about, do we have a proper process for incident response? Are we prepared to perform a proper forensic investigation and things of that nature? Application security talked about SAAS, DAS, RAST. When you're deploying application to cloud, are you using any cloud native features? Is it built securely? Are you performing your source code analysis and all of that? Data encryption is again another very very important topic, where you want to make sure that your encryption and the keys that you are using is very secure. You have to have a scalable key management. You have to understand who is managing the keys. Is the provider, or are you managing your keys yourself? Are you using hardware security module? Then identity entitlement and access management, again this is very very important. Identity is the new control plane, and cloud-based identity entitlement and access management is called the idea. It's crucial, and you make sure that you know who is getting what permission, have a very good access policy, access review, and make it everything is secure. I use least privilege principle to assign roles and permissions. Security as a service, again it's something where you can have security as a service model. A lot of cloud providers, they will give you integration tools, like Azure will give you the security center, where you can use it to implement security like by the click of a button. So you don't have to install like security tools and products that the way you do on-prem. You just click on some buttons, and security is provided as a service to do like incident management, access review and oversight, forensic investigation, things like that. And the last one is the related technologies. Is cloud IoT is big, AI ML is big data analysis. You have lots of newer and emerging technologies that you can use on the cloud, even cognitive services. Okay, that's amazing what Azure can do for you. So all of that. So to summary, a few things that you understand: the cloud security and responsibility model. We have gone over a few things that are the cloud definition of the cloud. Understand that. Understand what is user and who is the provider. Understand the cloud service model. Primarily three main one: infrastructure as a service, platform as a service, and software as a service. Understand the difference between the deployment model: public, community, private, and hybrid. And then understand the reference architecture, reference model for the cloud. One is built kind of on the top of the other. Okay. And then the logical model we talked about: infrastructure, metastructure, infostructure, appli structure. And finally, again, before you move to the cloud, go through the consensus assessment initiative questionnaire that I talked about, and for yourself use the cloud control metrics to figure out where you are, identify the gaps, and work on it. Hopefully you learned a little from the video. If you like the video, please give me a like, and let's meet on the next video, where I'm going to discuss the second domain in this particular series of lectures. Thank you for listening.